Good day to my studio audience and good day to my viewers at home, and welcome to another episode of David Cooks, starring me, David. We're going to be doing something a little different today. Instead of going through a step-by-step recipe of how to make something delicious, in honor of November's Diabetes Awareness Month, I have invited two special guests onto our program today. Dietitian Dr. Prasad and endocrinologist Dr. Brosher, to tell us a little bit more about what we should know about diabetes, especially since it's so closely related to the primary focus of my show.
Thank you for having us today, David. It's very important. Diabetes is the 7th leading cause of death in the U.S.
Yes, thank you again for having us, David. We're excited to be here to help raise awareness for diabetes. Before we jump into discussing the disease, there's something we should all be aware of. Even though there are two types of diabetes, type 1 diabetes or juvenile diabetes and type 2, both of them have to do with bodily dysfunctions that involve the hormone insulin. And you're going to be hearing us talk a lot about insulin on today's episode.
Of course, if we're going to talk about insulin, we have to talk about the organ that produces insulin, which is the pancreas. Do you know where your pancreas is, David?
No.
Well, why don't you stand up so we can give the viewers at home and the studio audience a little bit of a visual.
If you insist.
So your pancreas is located, just turn a little bit for me, right here, right behind your stomach, the back part of your abdomen.
Thank you. You can sit. So as we said before, the pancreas is located right behind the stomach, more upper than below, and this is the tail of the pancreas. Towards the end it's thinner, and the body or the head of the pancreas are the thicker parts of the pancreas.
Now, the interesting thing about this organ is, as big as it is, only about 5% of the cells that compose the pancreas secrete hormones, and those are called endocrine cells. And there are 3 types, and they are alpha, beta, and delta. And together, they form islets of Langerhans.
So, what are the other cells in this diagram here responsible for?
The acinar cells, they mainly produce and secrete enzymes involved in digestion. The pancreas has a lot of roles. Its endocrinal responsibilities are our primary interest, though.
Makes sense. The crux of diabetes is a hormonal issue.
It is. It's hormonal, and the cells that we're mostly interested in are the beta cells and the islets. They're responsible for producing all of the insulin in our bodies.
Of course, the pancreas produces other hormones too. Of an equally important value is glucagon, and that's produced by the alpha cells. And together with insulin, these 2 hormones manage one of the pancreas's main functions, and that's sugar homeostasis.
So you can see why, David, the pancreas is extremely vital to humans, because considering its role as an endocrine organ, how could we possibly enjoy the food that you cook?
Of course. It seems like we couldn't even live without our pancreas. Let's take a quick commercial break. We'll be right back to David Cooks.
Today's program is brought to you by the DC Bar. Are you diabetic and on different diets every week to manage your blood sugar? Looking for something that tastes great but is also healthy? Look no further. DC Bars, brought to you by David Cooks & Co., are full of fiber with 0 grams of sugar. Now available in 3 delicious flavors: chocolate, peanut butter, and butterscotch.
Welcome back to David Cooks. During the break, I was chatting with our gracious guests, and they have so much more knowledge to share with us today on our diabetes special. So, without further ado, Dr. Brosher.
Thanks, David. Now, before the break, we spoke about pancreas and its endocrinal functions. Now we're going to venture into the actual production of insulin, and we're going to find that that's at the heart of understanding diabetes.
So imagine, David, that I take a bite out of a muffin here, or I sip some tea, and sugar enters my bloodstream after digestion. Here, sugar is or glucose, so to speak, is our triggering molecule. It's taken up by a GLUT transporter and is processed in our mitochondria to produce ATP. ATP in exchange helps to shuttle insulin out of the cell. Through several protein cascades as seen here, but that's not important. What's important is that we essentially need glucose for cells to release insulin.
We can get a bit more technical here, so I hope everyone can stay with us. Insulin is a peptide hormone, meaning it's composed of amino acids, the structure which we'll get into when we talk about type 1 diabetes in our presentation. But what's most crucial to know is the mechanism through which insulin induces glucose uptake by the cells in our body.
You mean through our receptors and stuff, right?
You know more than me, huh? So yeah, you're right. Most of our cells carry insulin receptors, such as liver cells, skeletal muscle cells, and fat tissue. And that's because respiring cells need glucose in order to carry out their metabolic functions.
So as you can see here, the insulin binds to its receptor in the cell membrane. This receptor has an alpha domain and a beta domain. When it binds to the alpha domain, the beta domain becomes phosphorylated. That is, so to say, a phosphate group adds to the beta domain. And as we saw in the cell before, further protein cascades occur inside. But of these pathways, the one that we're actually most interested in is this one, the shuttling of more glucose receptors that are then added to the cell membrane. And recall earlier that insulin was secreted in a similar fashion where vesicles had secreted insulin, but here vesicles are adding more glucose receptors to our cell membrane. With an increase in glucose receptors in our cell membrane, we can take up more glucose.
Oh, insulin ensures that our cells have enough channels to take in glucose from the blood?
Yeah, you've got it. With this mechanism in mind, we can explore how type 1 and type 2 diabetes come to be. So, as I mentioned before, insulin is a protein, which means it's composed of amino acids, which we're seeing here. But the reason this structure is so crucial is that as a protein, insulin is a product of gene expression.
You mean that our DNA codes for insulin?
That's absolutely right. So recall before that the mechanism for insulin secretion involved the exocytosis or the release of insulin, which kind of implies that this insulin was made beforehand and it's being stored in the cell. So at some point the cell is storing insulin for a future purpose, which is when we eat, the glucose intake is going to trigger this insulin release.
So our cells are equipped with the machinery in our chromosomes to express any protein product, provided that the particular gene encoding the protein product is turned on. So insulin is manufactured in our beta cells when the insulin gene, or the INS gene, is turned on. We mention this because it's going to help us understand the mechanism of type 1 diabetes, also known as juvenile diabetes.
This is the rare diabetes, correct?
That's right, it is. It affects only 5 to 10% of the people who are actually diagnosed with diabetes in the United States, which means that the majority of the people diagnosed with diabetes in the United States are not bothered by type 1. It's type 2 that they have to worry about. But what you need to know about type 1 diabetes is that it's an autoimmune disorder, meaning that our own immune systems, particularly the bad guys or T cells, they tend to attack, ironically, the beta cells of our pancreas. And as we just learned, the beta cells produce this insulin.
So now remember what we said before. Only our beta cells produce insulin. So if our pancreatic beta cells are destroyed, we can't produce any insulin, and the cells in our body are not going to be able to take in any glucose. So that just means it's going to build up in the blood, and we call this hyperglycemia, or high blood glucose. So this causes so many complications for the individual affected. They're going to have cardiovascular disease, so that's heart disease. They're going to have troubles with their kidneys and with their nerves and so many other complications.
Of course, the easy fix for this would be to give these patients insulin, whether it's between a meal or before they sleep. The doctor tends to figure out when they should take insulin, but it's also very important for them to manage their diets and to exercise, just to avoid any unnecessary and possibly hurtful spikes in their glucose.
That makes sense. They have to be on the lookout for blood sugar often too, right?
Yep.
Yeah, it's really important that diabetics test their blood sugar daily, especially like before meals and a couple hours after they've eaten.
Well, that makes sense. Heard a little fun fact that insulin was originally harvested from pigs.
Well, that's true. They actually used to use the pancreas of pigs to harvest insulin, but now they use recombinant DNA, which is basically injecting the insulin gene that my colleague here spoke about before into bacteria. And because bacteria tend to replicate very quickly, they can produce batches of insulin that the pharmacies tend to use and sell as insulin for these type 1 patients.
Fascinating. Well, let's cut to a quick commercial break and hear from one of our sponsors for today's episode.
Have you or a loved one been struggling with juvenile diabetes? Does your insulin not work as efficiently as it used to? Then try Insulin. The insulin that ensures healthy blood glucose levels with a faster absorption rate, easy administration, and on-the-go convenience. Call your primary care physician today to see if insulin is right for you.
Welcome back to David Cooks, everyone. Before our break, these brilliant doctors were discussing juvenile diabetes with us. Now, tell me about type 2 diabetes. How is it different from type 1? Do you treat these diabetes with insulin?
No. So administering insulin to type 2 diabetics would pretty much be pointless just because the mechanism is a little different than type 1 diabetes. So type 2 diabetics they don't have problems with the production of insulin or their beta cell functionality. Rather, their cells have grown so insensitive to insulin that it's no longer effective.
But how exactly does that happen, though?
So that's the thing. We don't really know. They kind of believe that there's an accumulation of lipid metabolites in our cells, and this is mostly seen in obese populations. So that what happens is that even though insulin might bind to a cell receptor, it does not trigger the internal cascade, and so we're not having any glucose receptors being added to the cell membrane, as we saw in the diagram earlier. And what's going to happen is that the cell is going to be incapable of taking up glucose, and if the cell can't take up glucose, it's going to remain in the blood, which is going to result in hyperglycemia.
So, even though the insulin is properly binding to the receptor, the effects aren't conducted properly, and therefore no glucose will be taken into the cells. So the cell is considered to be desensitized. So the accumulation of glucose in the blood leads to hyperglycemia, which is what we mentioned before. And not only does hyperglycemia occur, but there are other complications associated.
So you see, the hardest part of this is treatment. They don't lack insulin, they have insulin, but what they're not doing is that their cells are incapable of responding to this insulin, and it's hard to make a cell respond to insulin when diets and obesity have caused the cells to become desensitized.
So how does one treat type 2 diabetes? Since, as you mentioned, about 90 to 95% of diabetics in the US are type 2.
Yeah, that's right. And this population also overlaps with the obese population. So many of the patients that are diabetic are also overweight, and our primary goal is to encourage exercising and a healthy weight loss alongside the use of medication and managing blood sugar.
How do these meds work if their cells are insulin insensitive, though?
Well, another primary culprit of insulin sensitivity is the overproduction of glucose by the liver. So medications such as metformin work by decreasing hepatic or liver gluconeogenesis, or the production of new glucose from the liver.
Likewise, I work closely with Dr. Brocher to manage the patient's diet because it's essential not to take in certain types of foods while you're a diabetic. Foods that are too high in carbs or simple sugars or high fats should be avoided, just in an attempt to get back to a healthy weight and to try to resensitize these cells to insulin. With that, I believe you have a recipe to share with us.
I do, in fact, a diabetic-friendly, gluten-free, vegan pumpkin cheesecake. You can find my recipe on my website, www.davidcooks.com. Also, don't forget to check out our new book, out in local bookstores next week, Love Your Pancreas. Let's have a round of applause for our special guests today, Dr. Brocher and Dr. Prasad. Tune in next week for our special guest, Dr. Chakraborty, who will be discussing the risk of diabetes in menopausal women.